Hi everyone, my name is Alfa. I'm a research staff at the University of York. In the next 20 minutes, I'm going to present our paper that has been accepted as this workshop. The paper pretty much discusses a tool that is designed to automate the development of decentralized data vault applications. I'm on behalf of my colleagues, Alfonso, Dela, and Dimitris will do the presentations. So let's start. The outline of these presentations is as follows. First, I'm going to talk about the background of the motivation of this research. After that, I will explain briefly what we call data vaults in the context of our work, and then I will also explain a bit about Fairnet, a mini example of a decentralized social network application generated by our tool Vaultage. Afterwards, I will explain more about Vaultage and then present the result of our early evaluation. I will end the presentation with conclusions and future work. Most of the online services that we use nowadays are centralized. This means that they require users to upload their data to the service provider's systems. To some extent, users need to trust the service providers that they will protect and use the user's data legally. However, we cannot really have control over our data, and we doesn't know what they are going to do with our data. How will they process our data? Yes, it is right that users' data are protected by terms of services and GDPR, the General Data Protection Regulation, but they can only protect users' data legally, not by design. It means that by design means that we should protect users' data through the architecture of the services of software that they use. One way to do this is by going decentralized, that is, keeping the data stays on users' devices and provide services and access control for external entities that want to use the data. That's why we have been working on a tool that we call Vaultage, a tool that can simplify the development of decentralized data vault applications. What we mean with data vault in our research are conceptual or abstract nodes, which can be user-managed devices that can give users more control over their data. A data vault should at least have two capabilities. First, it should be able to store data in certain schema. For example, a medical application might store data about patients and treatments. Second, it should be able to receive external requests and send back responses appropriately to the requesters. This way, we could have many vaults that can exchange messages between them. So if we want to use data vaults in our architectures, first we should define the data vault schema and then the data vault operation request. Using this approach also comes with challenges. The first challenge is data availability. The data availability. Data might not always be available since users can turn off their devices or blocked by firewalls. The second challenge is the reduced performance because users' devices are not optimal compared to dedicated servers. The third challenge is data validity. No guarantee that the data that we request from an external vault is valid, correct, or trusted. The fourth challenge is the communications. Decentralization makes message exchange more complex. For example, network configurations, routing firewalls, handling parallel requests, synchronizations, and many more. So Fairnet is a minimal decentralized social network application generated by our tool Vaultage. It has a data vault schema that stores the profile information of a user, a list of posts created by the user, and also a list of friends of the user. It has the following operations or services that can be requested by external entities. The first one is add friend. Add friend is a service so that other users can add a user as their friend. Second service is get post. Get post is used to get a specific single post created by a user. The third one is get post is to get all posts created by a user. We will see in the next following slides how Vaultage works to produce the schema and operations. Vaultage is a tool that we are currently developing to generate centralized data vault applications such as Fairnet. In the following slides, I will show you how Vaultage works in generating Fairnet in terms of the data vault representation, network architecture, encryptions, and code generations. So we use emphatic language to model the data schema and the operations. The data schema is translated into fields of a vault class, including with their types such as names, friends, and post there. A vault class means it is a class that is responsible for declaring data schema and also operations for external requests. The vault is annotated with @vault. The available operations such as @friend, getPost, and getPost are expressed as operations in the vault class, including the required parameters and the types of the return values. The rest of the classes here, such as posts and friends, are to define the types and structures of entities required in the schema. This is the network architecture of Fairnet generated by Vaultage. In the network, we have many vaults that represent many users, and every vault resides on its user's private device. Message exchange between these vaults is carried out via a broker server. Every vault has a unique public key, and it is used as an identifier of the vault of the message broker. So if a message is sent to specific public key, it means that message is intended to the vault of the public key. So if Alice wants to add Bob as her friend, she has to send a friend request to Bob using Bob's public key, which Bob has already shared to her before through other channels such as emails or WhatsApp. The friend request contains Alice's public key. This key can be kept by Bob to further identify Alice if she is allowed to request Bob's post. If Bob's agree, he sends a response back to Alice indicating that her friend request has been confirmed. All messages between vaults by default are encrypted using asymmetric encryption. We also apply double encryption, which means messages are encrypted using receiver public key and sender private key. In our current implementation, we use built-in Java RSA for key generation and bouncy castle for ciphering. These are the classes generated by Vaultage. The Vault class has the attributes defined in the data schema and defines the logics of the available operations that can be requested externally. The remote vault class is a class that is used to send requests to another vault to call its operations. The internal entity classes are other classes defined in the data schema in the data vault model. The response handler interfaces are interfaces that have to be implemented in order to define response when a reply from a requestee or remote vault is received. For example, the add-friend response handler is used to define what Alice's vault should do after receiving a confirmation that her friend request has been approved by Bob. The message handler classes are classes that are responsible for calling appropriate operation defined in the vault class when a request is received, and also for calling appropriate response handler when a reply or answer from requestee or remote vault is received. The last one is the broker server launcher. It's a class that is responsible for launching the broker server. So far, we have developed 3 minimal projects to evaluate the code generation capabilities of Vaultage. The first one is Fairnet, decentralized social network application. The second one is Pollen, a polling application with multi-party computation. The third one is Synthesizer, an internal tool to measure Vaultage's performance. We also have evaluated the degree of automation of Vaultage by comparing the number of lines in the input model versus the number of lines in the generated code. Here are the results. Yeah, we are still at the early stage of our development. We expect this ratio to further improve as Vaultage matures and extra functionalities are covered by the automatic generation. We also evaluated the performance between unencrypted and encrypted messaging in terms of execution time. We found that encryption and decryption of messages imposes 37% penalty over the total time to complete messaging tasks. In these sessions, we have presented Vaultage, a model-based development tool to simplify the development of decentralized data vault applications. It allows data exchange between data vaults through secure and brokered messaging. For our future work, we plan to support direct messaging between vaults to improve the performance of messagings instead of using broker servers. Second, we plan to support synchronization between user devices to maintain copies of their vaults over multiple devices. And that's all from me. Thank you for your attention.